Howdy folks, Eric Darling here with ye old Eric Darling data. And I want to show you a kind of a funny little performance tuning shortcut that actually came in handy earlier this week. Now, when I'm working with clients, my job is to get them the fastest possible solution to their problem that that it's like possible, right? So it's like sometimes I can touch more stuff than others, other times I can touch less stuff than others. Either way, my job is to get people moving faster in a hurry. Sometimes, like, in a perfect world, we could all take a lot of time to perfectly tune this, that, and the other thing, to change, functions and indexes and queries all over the place to get the perfect code. Other times, we can take what I like to call the Band-Aid route, and we can put a Band-Aid on it that gets us to a much, much better place for now until we can get to that wonderful Arcadian pasture that is perfect performance. I know, right? So what I'm going to show you is something that came in handy earlier this week when I was tuning. It was a much bigger query than the one you're looking at on the screen. It was a big tangle with like a 500-line where clause and all this other stuff. And there's a lot of complex stuff going on, even in the select, like case expressions and whatnot. But what it came down to was that there were a bunch of functions. Now, in the query that I'm looking at, I only have one function, and it's called initial cap. And it does exactly what it sounds like. It'll take a string, and it'll make the first letter a capital, and it'll make any letter after a space a capital. It's a scalar-valued function, and while we're all breathlessly awaiting these things not sucking in SQL Server 2019, there are a whole heck of a lot of us who have to deal with versions of SQL Server that do not have the magic of Freud. Now, the real query that I dealt with had a bunch of formatting functions in it. So, like, there were a whole bunch of things that formatted, like, phone numbers and postal codes and dates and all this other crazy stuff. And I know what you're thinking. You can't just, like... use convert to formatted date? No, apparently not. Apparently you need a scalar-valued function to do that. So rather than sit there and rewrite every single function and mess with logic and results, here's what I did. Now I'm going to show you exactly how this reproduces with this query. I'm going to turn on query plans, and I'm going to fire this thing off. And this thing is going to run for around about 11 or 12 seconds. And part of the problem with the way this query runs is that because of this scalar value function in there, it's forced to run serially. Now, another problem that scalar valued functions have is that they run once per row, not once per query. We can kind of see that if we look in the query plan and we look at this compute scalar operator. If we hit F4 here, we can see that this is where that init cap function gets called. Right, so that's where we do it. But we do it at the very end, and we only do this over 500 rows. So this function running 500 times isn't going to be a big deal. What's a much, much bigger deal for this query is that it's forced to run serially. If we look at the properties of the select operator, we have this non-parallel plan reason could not generate valid parallel plan. This started in the SQL Server 2012 plan XML. This would start showing up in there. So if you're on 2008 or 2008 R2, you're not going to see this. If you're on 2012 plus, you will see that if you have some construct in your query plan forcing things to run serially. Now, since there were a bunch of functions in the actual code that I was tuning, what I decided to do was, rather than spend my time and waste someone's money rewriting a bunch of functions and trying to toggle with indexes and this, that, and the other thing, I just wanted to see how the query ran if I took the functions out. And that's what I did in this query right here below it, is rather than have a reference to the formatted display name, I just have the display name. So I coded out the functions, and I kept the columns in that the functions were formatting. And oops, I hit F5, but I highlighted the whole thing. As a professional query performance tuner, I cannot impress upon you enough the importance of highlighting the entire query. So I highlighted the entire, in real life I highlighted the entire query, and I hit F5, and it ran much faster. That finished in 2 seconds rather than, what, 12 seconds or something? Yeah, 12 seconds. So we improved this query by 10 seconds just by not having the scalar function in there. Of course, the reason this query runs much faster isn't because that function did anything so heinous. It's because this query was allowed to go parallel. So now that we have all this parallelism going on in here, the root query finishes much faster. Now, there are a lot of caveats. I'm not saying that a query going parallel is always a good thing, or that you should have as many queries going parallel at once as possible, because that has effects on concurrency, how many threads get used by queries, how many threads get used by your overall workload. But in this case, it didn't hurt too much. So what I did is I took that query and I said, well, you know what? This query gets us close to what we need. We just need to format that data at some point. And I'm going to tell you something about scalar valued functions, and that in small doses, they're not that bad. In small doses, they're okay. They're not too terrible. Which I know is like not a great thing to say. Like everyone's like just going to come up with torches and pitchforks and tell me that scalar valued functions are the devil. And a lot of the times I'll agree with them. But in this case, where we're just formatting data. The scalar valued functions aren't like going out to other tables and doing all sorts of other crazy things. We're just formatting some data in place. Well, that still will suck, but we can make it suck a whole lot less if we don't let it impact our big queries, and if we only do it on a limited number of rows later. So what we can do, and this is a trick that you can try out, is if you have your big queries with lots of scalar valued functions in them, and you don't want to rewrite a bunch of scalar valued functions and have a whole bunch of awful things. I get it. It's hard. It's daunting. But what you can do is you can take your big, mean, nasty, awful queries, and you can dump them into a temp table. And the dump into a temp table will still take about 2 seconds to finish. Right, so we hit that still takes, you know, a couple seconds to get the data into the temp table, but it's a lot faster than the 12 seconds that we waited for when we just needed to select all the data. And then after we have data in a temp table, well, now we can just call our functions on what's remaining. So now if I hit F5 here, well, that finishes just about as quick as you could want it to finish. So we still have we still have a big query that we have to run and do stuff with, but that query isn't impacted by the side effects of scalar valued functions. So that's one way to kind of skirt around the issue and then get the data get whatever the scalar valued functions need to do at a later point. Anyway, I thought that I would share that with you in video form because I care about you and I care about the health and well-being of. No, I'm kidding. Yeah, no. Good luck. Good luck. I wish you luck out there. Anyway, I'm Eric Darling. Thanks for watching. I hope you learned something. I hope you enjoyed yourselves, and I will see you in some other video some other time.